which I just mentioned, and you need chemistry specific skills also. And then your personality, your values, your attitude, your traits. These three things taken together determine your competence in any profession. Even in your teaching profession, you will be able to excel only if you have all these three things. Therefore, the goal of quality education should be to acquire competence. And this summarizes. Note down this slide in mind. For competence, you need to have knowledge, skills, and personality. And competence will lead you to excellence in any profession. The nature of knowledge, for example, if you are an engineer, the nature of the knowledge may be different. Nature of the skills may be different. If you are an IAS, you need knowledge of a different type, you need skills of a different type. But all these three things ultimately will determine your competence in any profession. And now I come to part 3, where I would like to cover. So, in the light of all that, we need in our country in the 21st century to focus on enhancing the quality of chemistry education in the country. Please remember one sentence: education is relevant only when it is able to serve the needs of the changing society. Otherwise, education has no meaning. And in any education, three things are important: what do you teach, how do you teach, and how do you assess. And in India's education system, unfortunately, we have not changed. We have 21st century students, but the content which we teach sometimes is of 19th century. Our methods of teaching, our assessment methods, our courses architecture, all old, outdated. We will have to change. Look at curriculum. Curriculum is what? Curriculum is the total learning experience. And the biggest challenge to curriculum is coming from the growth of chemistry knowledge. The knowledge in all disciplines is growing very fast. So fast that the doubling time has shrunk considerably. Look at chemistry. Chemistry people produce new substances in the laboratory and it is growing. See, by the end of this century, we expect 5 billion chemical substances. Today we have about 80 million. So that shows the growth of chemistry knowledge, because every substance has to be unique. Then increase in the number of elements in the periodic table. We have currently about 118 elements. These are the 100 last 6 elements. Then many new and modern instruments are coming. Then, many new concepts, theories, and ideas are emerging on the chemistry scene, which we do not know and which we never teach our students. We still teach old, outdated things. And that is the reason many new sub-disciplines of chemistry have come. Chem informatics, combinatorial, green chemistry, sustainable chemistry, medicinal, all that. New areas of research have come. But foundations come from chemistry education. And please remember, note down this point in for you. What we know is merely a drop, and what we do not know is an ocean. That's the reason why NEP says we should revise syllabi more frequently, because the way the knowledge is growing, curriculum becomes outdated as soon as it is created. We should have light syllabi so that students have more time for thinking. Light syllabi but modern. We should have skill-based and industry-led curriculum. We should be aware of what industry needs, what type of skills we need, and then accordingly we should teach. See, Professor C.N. Rao, the famous chemist of India, he says 90% of the universities in India have outdated curriculum. So you can very well see. Then comes pedagogy. Pedagogy is how do we teach? It is art and science of teaching. And here also we will have to change. We still teach by the traditional talk and chalk method. which is teacher-centric. We must embrace learner-centric pedagogy. Many new methods have come. Problem-based learning, project-based learning, collaborative learning, flipped classroom, experiential learning. We need to foster critical thinking skills. And please remember, era of rote learning is over. Don't encourage rote learning in your students. And then need to follow an integrated approach to teaching. We generally teach subjects in isolation. If I am teaching physical chemistry, I will teach only physical. And if something comes from organic, I will say this is organic, as if it has nothing to do with me. See, present day world is focusing on interdisciplinary research, which is the need of the hour. Don't teach subjects in isolation. For example, in organic chemistry, so many reactions, so many mechanisms. From where do the mechanisms come? How you determine the mechanism? They basically come from chemical kinetics. You should have the full knowledge. And you should understand the thing. For example, I tell you, I teach these subjects in Delhi University. I have taught all these 4 topics we teach. But look at, see the connection which we never tell to our students. Upper zones, quantum mechanics and statistical mechanics, they are theoretical methods. Quantum mechanics is dealing with microscopic matter, individual atom or molecule, theoretically. And it gives you the wave function, which is the storehouse of information. Statistical mechanics deals with macroscopic bulk matter. For one atom, you will use quantum mechanics. For 1 mole of atom, you will use statistical. And here the storehouse of information is partition function. See the connection, both are theoretical. Now come to the bottom. The results of quantum mechanics are verified through spectroscopy, which is an experimental science. Because quantum mechanics will predict quantization of energy level, discrete energy level, so that transitions can take place. So that is what comes in spectroscopy. In statistical mechanics, you deal with the bulk, you deal with bulk properties, which you experimentally measure in thermodynamics. So you can see the connection between the 4 topics. And we teach in our universities as if they have nothing to do with each other. This thinking is missing in our teaching. And then comes assessment.